Okay, I already started this video once and realized something was wrong, so I've had to make a change. You can ignore the yellow over here. That just means I have to do something special when I go to upload the code where you guys can see it. You'll notice that my backdrop is different. Normally I am filming in my big red chair at home. I am currently house sitting for my uncles this week, so most of the remaining videos, if not all of them, will have this backdrop, which just so happens to be my uncle's finished basement, with the exception of the last parts of the videos, which will be demonstration pieces of the code that I've written, with the exception of a couple of videos. That being said, this week we're talking about digital inputs. Digital inputs are simplistic switches. A digital input could be any number of things. A light switch, a button on a video game controller like the AXBY buttons. It can be a button on your radio in your car, on a television remote. I'm just sort of looking around my uncle's house right now trying to find different things that we consider a digital input. Generally speaking, if you're talking about robotics, digital inputs are used to limit motion. You've probably heard somebody say in the past, if you're not completely new to FRC robotics, someone mentioned a limit switch. Limit switches are digital inputs, and they tend to be used to limit motion. And that's what you'll see a lot of digital inputs getting used for, is to know when something is in a certain position where you want it to stop moving. For example, the bottom of our elevator on last year's robot had a limit switch that would stop the motors from turning if the elevator was all the way down. This was to prevent us from burning out the 775 motors that we had on the elevator. What we're going to do this week is see three different things. Well, I shouldn't say this week. This stage, because I'm going to be filming a lot of these in one night, is a little bit of how to set up an autonomous, a little bit of how to use digital input. It's pretty straightforward. And a little bit about the smart dashboard, which is basically just a way of sending feedback to your robot. Now, one thing that I will mention that I may not have mentioned in earlier videos, I can't quite remember, is the smart dashboard is being replaced with something called Shuffleboard. But just so you are aware, anything that you do with the smart dashboard will translate directly to using Shuffleboard. I am not aware if Shuffleboard is replacing smart dashboard this year, but it is going to be quite a bit different than how it looks right now. But that being said, the example that we're about to look at builds off of the last video's example where we were talking about how to build code for a drivetrain. And several of the videos that come after this one will be built upon the code from the previous video. So just keep that in mind. If you decide to skip a video for one reason or the other, you may see extra code that I don't talk about, that was talked about in a different video. Generally speaking, I will give an overview of what each piece does anyways when I'm talking about it in each video, just maybe not as in-depth as another video. With that being said, let's talk a little bit about what's changed. So all of these pieces here are the same from the previous video. You've got all of your speed controllers, all of your motor controllers, whatever you want to call them, as long as they're named this when you're writing your code, are defined here. You've got speed controller groups, the left side of the drivetrain and the right side of the drivetrain, and you've got differential drive, which is how we control our robot as one concurrent unit. We also have an Xbox controller object so that we can pull information about how we should be controlling our robot. And we have something new. We have a new variable that we create called bumper button. On the front of my robot, as you'll see later in the video, there is a big red friendly button on the front of my robot that when it bumps into something, at least this is how the code is going to work, when it bumps into something, it's going to make the robot stop while the robot is in autonomous. This is probably one of the more basic uses of a digital input. It doesn't get too much more complicated than this. There are some digital input devices that can be a little bit more complicated, I guess would be the best way to put it, but most of them follow the same general theme, at least for what we will be using them for. Just as a word of caution, I wouldn't necessarily use a bumper button on the front of a regular FRC robot. As I've mentioned in the past, even though my robot has gone through a competition before, thanks to all of you, my robot was never really designed for that. It was designed to be a demo and test robot. So it's generally not a good idea to have random protruding sensors sticking out of any side of your robot, let alone the front. So you'll notice that when my robot is performing its demonstration of this code, it will be moving quite a bit slower, and we'll see where that is implemented here in a minute. If we go down to robot init, we'll see that all the same stuff from the drivetrain example is there. We create our motor controllers, we create our speed controller groups, and we create our differential drive, each piece being based off the last. We also create our Xbox controller object called controller so that we can control the robot in teleop. And then we create this bumper button digital input. Now if you notice this 0 here, we see a lot of zeros. There's multiple zeros here. One is for PWM, that's for this Victor SP. One is for the Xbox controller, that's for USB. And then this one here is for the DIO, the digital I/O rail, the digital input and output rail on the RoboReel. This is the extra set of pins on the opposite side from the PWM rail that allows you to take in digital inputs and output digital signals. Output on and off signals, take in on and off signals. And what we do is we create the digital input on DIO 0. Now, we didn't talk about this in the structure video, but it does exist, and I did mention that there were some methods that didn't appear in that video that may appear in later videos. Robot periodic is very similar to the other periodic methods. It's called once roughly every 20 milliseconds, although not always exactly. And robot periodic is good for really, really quick general information updates, like if you were trying to put something to the smart dashboard, which is what we're using it for. It's good for things that have to run on your robot always. Once your robot boots up and robot init is finished, you want these things to be running all of the time. Generally speaking, robot periodic is going to be a little bit more sensitive than the other periodic methods because you can start to slow down everything with robot periodic. For example, it makes it very easy to delay the amount of time it takes for your robot to switch between modes, like switching from autonomous to teleop, or even disabled to autonomous when a match starts, sort of deal. So you really need to be careful what you put in robot periodic. Keep it short, keep it simple. Don't make the robot put too much effort in robot periodic. But that being said, the only thing that we do is put a Boolean value, a true or false value, on the smart dashboard called bumper button pushed. And then we give that a value. Now, the way we retrieve the value from a digital input is with a method called get. Get returns a true or false value. Now, the weird thing about the digital input on the RoboReel is that depending on how you hook the switch up, depending on how you hook up the digital input, the limit switch, whatever you got, whether or not it's true or false changes based on how you hook it up. This is referred to normally open and normally closed, and generally speaking, it's a little bit outside of the scope of this video. However, what I will say is, in this instance, when the button is not pressed, the value will be true, and when the button is pressed, the value will be false. Now, that's backwards from what we want it to show on the smart dashboard. We want to know if the bumper button has been pushed. Well, in order to do that, we have to invert. We have to make false true and true false. There is an operator called not, literally called not, that can do that for us. And in Java, it's represented by an exclamation point. So what happens is, let's say that the button is not pressed. If you remember what I said, that when the button is not pressed, the bumper_button.get method will return true. We want to make that false because the button is not pressed. So what we do is we put a not in front of bumper_button.get, and that will make it so that that value is false when the button is not pressed. Likewise, when the button is pressed and bumper_button.get is returning false, the not symbol will automatically make that value true. That's a very quick rundown, and obviously, as I'll mention at the end of this video, if you have any questions about why that is or how it works, we can talk a little bit more about the electronics associated with why that is. There is a electronics concept called input pull-ups that makes the logic a little bit weird. But generally speaking, just for this video, know that when I do not bumper_button.get, it just means that I'm trying to reverse the value to make sure that it's representative of whether or not the bumper button is being pushed. Now, if we quickly look at autonomous periodic, we see that we have some new autonomous code. And basically what the code says, as long as the bumper button is not pushed, drive forward at roughly 40% speed. Tank drive obviously giving you the ability to control each side of the drivetrain individually. We make the numbers the same so that the robot drives forward at a consistent forward speed. I chose 0.4 and 0.4 simply because it seemed like a safe speed when I was testing. You could make it 1 and 1, but I don't know that my little button bracket that I printed would hold up to a full 10 feet a second impact from my robot. It would probably shatter. That being said, so I guess I didn't do this the right way around, because we haven't talked about if statements yet. So if statements in Java are mechanisms by which we can ask questions. They take in a true-false value or multiple true-false values, and using that information, they determine what they're supposed to do. So in this instance, we're saying if the bumper button is pressed, then drive forward. If it's not pressed, or just simply otherwise, stop. 0 and 0 just means stop. Because if you remember, I think I had mentioned previously that the values for controlling tank drive and arcade drive are -1 to 1 with decimals in between. 0 being stop, -1 being technically full reverse, and +1 being technically full forward. That being said, this is probably one of the more basic autonomous codes that you could possibly have. And it really doesn't do much. For example, if in this case, if the bumper button gets pressed and then whatever the robot ran into moves, for example, another robot, then the robot will continue to go forward, provided that the autonomous period is still going on. You may not want that to happen. Depends on what you really need to do in autonomous and what you need to change in order to make that work. This was a very, very fast rendition of digital input, and probably most of these videos will be very, very, very fast because I'm working on limited time. So obviously, if you have any questions, please let me know. I do want to mention in this video, and I will probably mention it in the next several videos, starting on December 21st and going until kickoff, more than likely I will be unavailable due to the fact that my surgery was scheduled exactly 2 weeks before kickoff. So I am hoping to be properly recovered, but of course, if you have any questions about any videos, you can leave me a question either in my email inbox, send me a message on Facebook, get a hold of somebody else to get a hold of me. If you have my cell phone number, you can send me a text message or leave me a voicemail if I can't pick up. But, of course, I want you asking questions if something is confusing. That being said, the next part of this video will be the demonstration of this code. Hopefully it works correctly because I did just make a change. The next video we will cover analog inputs. Otherwise, more specifically, we'll be covering analog potentiometers, which is a type of analog input. Other than that, I don't think there's anything else for this video, so next stage coming right up.